Let's look at our last example from related rates. All right, so this example says, every day a plane flies directly over my home at a constant altitude of 4 miles. If I assume the plane is flying at a constant speed of 400 miles per hour, at what rate is the angle of elevation of my line of sight change in respect to time when the horizontal distance between the approaching plane and my location is 3 miles? All right, so what's going on? Maybe I'm over here, okay? The plane is right here, flying horizontal like that, okay? Now, the angle of elevation of my line of sight, I'm looking at the angle right here. So the angle of elevation of how I see the plane, basically, okay? All right, now, what do they talk about this altitude? Yes, this altitude my plane is flying at is 4 miles, right? All right, so what do we have here? We have a right triangle, don't we? All right, let's see. Every day a plane flies directly over my house at altitude of 4 miles. Got that. If I assume that the plane is flying at a constant speed of 400 miles per hour, so this thing's moving at 400 miles per hour. Okay? At what rate is the angle of elevation of my line of sight changing with respect to time? At what rate? At what rate? So that's going to be a derivative, right? At what rate is this angle of elevation? So I'm looking at the change in theta. At what rate is that changing? That's what I need to find. At what rate is that changing with respect to time? And the horizontal distance between the approaching plane and my location is exactly 3 miles. Whenever that horizontal distance here is exactly 3 miles. Let's call this something, maybe like x, okay? So what are they asking for? Whenever this horizontal distance, x, is equal to 3. Okay? Round your answer to the nearest degree per hour. Usually I have more than one derivative. I have a derivative I have to find, and then I have a derivative that's given to me. Actually, there was a derivative that was given to us. 400 miles per hour. That's a rate of change, right? And which part of my triangle changes at 400 miles per hour if my plane is flying that way? This x part's going to change, right? So the change in x with respect to time is going to be negative 400 miles per hour. All right, so what do I need here? I need to take the derivative of an equation with respect to t, right? That equation, I want to have theta and x in it. Look at your triangle here. Find an equation with theta and with x. With theta and with x. I would say something like the tangent of theta is equal to opposite over adjacent, or 4 over x. Some of y'all want to use the cotangent as x over 4, that's fine as well. All right, now I could take the derivative of both sides with respect to t, but I'm going to have to use a quotient rule if I do that. To avoid that, I'm going to multiply both sides by x. I get this. And maybe I'll go ahead and, if I try to take the derivative of this, I'll have to use a product rule, right? So maybe I'll go ahead and divide by tangent of theta. So x is equal to 4 over tangent of theta. Or could I write this as x is equal to 4 times cotangent of theta there? Now I'm not going to have to use a product rule because this is just a constant, right? So let's take the derivative with respect to t of both sides. So I have dx over dt is equal to 4 times the derivative of that. What's the derivative of cotangent? Negative cosecant squared, right? But I need times the derivative of the inside. What's the derivative of the inside with respect to t? D theta over dt. All right, let's fill in. What's dx over dt? Negative 400 is equal to negative 4. I'm going to call this cosecant of theta squared like that times d theta over dt. I'm just going to keep like that because that's what I'm trying to solve for. Now let's find my cosecant of theta. Cosecant of theta. Well, let's think about our triangle again, okay? Here's my triangle right here. Here's x. Here's 4, right? Here's theta. What am I looking at? I'm looking at whenever x is equal to 3, right? So I'm looking at when x is equal to 3. So I'm going to call this x value 3. All right, so what would my cosecant of theta be? What is cosecant? Cosecant's what? Hypotenuse over what? Over opposite? So find your hypotenuse. If you use the Pythagorean theorem, you get 5. Remember 3, 4, 5 triangle? So what's the cosecant of theta right here? Cosecant's a reciprocal to sine. Sine is 4 over 5. So cosecant would be 5 over 4. So what am I going to put in for the cosecant here? I'm going to put in 5 over 4. Still need to square it, times d theta over dt. Now I'm just going to divide both sides by negative 4 to make the math a little easier. So that gives me positive 100 is equal to, if I square this, I get 25 over 16 times d theta over dt. All right, now what do I need to do? I need to multiply both sides by the reciprocal here. So I'm going to take 16 over 25 times 100 is equal to d theta over dt. I can put that over 1, and that divides out. That leaves me a 4. So 16 times 4 is 64 is d theta over dt. Now, what do I have here? I have 64 what? Change in theta with respect to time. So units of theta over units of time. What are my units of theta? Remember, anytime in calculus, unless it says otherwise, we're in radians, not degrees. What's my time in here? Hours, right? So I have 64 radians per hour is how this angle's changing. But look back at your problem. What do they say? They say they want the answer in what? Let me find my paper here. They want the answer, round your answer to the nearest degree per hour. I have radians per hour, so I need to convert that to degrees per hour. So what am I going to multiply by? 180 degrees over pi radians. And think about it, you're going to have degrees over hour, degrees per hour. And if you round to the nearest one, you get 3667 degrees per hour. There we go. Good luck.